Alright, this is the Module 4 Excel report for Miss Benzie's class. So, number 1, it says how many people want to move away and how many people want to stay in their country as worldwide poll from 2008 to 2010. 10% of Canada and the United Kingdom wanted to move, whereas 34% of the United States wanted to move. That means that 240,000 out of a million wanted to move. 70,000 out of a million wanted to move in the countries of the United Kingdom and Canada. 71% of the worldwide poll wanted to move away, whereas 29% of the worldwide poll wanted to stay where they were located. P.S. I have no clue why the pie chart would not display accurate data. I have highlighted over cells B5 and C6, but it is displaying inaccurate data. Moving along to number 2. Alright, number 2 is talking about a function that you have to tell a story. My story was about Tommy's bank account. Tommy put $2 in the bank, and every day he set up his account to deposit 75 cents in his bank. Over time, his account grew, and on the 23rd day, he had a total of $19.25. On the 6th day, Tommy will have $6.50 in his account. On the 16th day, Tommy will have $14. The function 3/4 x plus 2 was represented by Tommy's bank account. I'm sorry, every time I press the down arrow to go down, it for some reason goes all the way down to the bottom. I have 2 graphs showing the different data. Alright, moving on to number 3. Excuse me, I'm recovering from a cold, so. Alright, number 3 is about profit from a shoe sales. The formula to model the sales of a sneakers company is P of X times 4X squared minus 3X minus 240. I've highlighted the areas where 0 sneakers were sold. The initial investment was $240, so they were negative $240. And at 4 pairs of sneakers sold, they were at a negative 304, which was the lowest that they were negative. After 13 sales, they broke even, and at 19 sales, they get a profit of $500, at least. So, a shoe company just woke up. Wow, that's amazing. Well, the initial investment was $240. When they sold 4 pairs of shoes, they were at the lowest with negative $304. They broke even after selling the 13th pair of the shoes and made a profit of $500 after selling the 19th pair of shoes. The formula that was used was PX equals 4 squared minus 32x minus 240, and it was represented in this equation. Moving on to number 4. Formula to model the height in feet depending on the time in seconds. The formula is height h of t equals negative 16t squared plus 131t plus 7. So it took 4 seconds to reach its highest point at 275 feet, and at 9 seconds it broke even with the ground. At 4 seconds, the highlighted area on this question displays where the ball was at its highest point and where it fell. The formula that was represented was h of t equals negative 16t squared plus 131t plus 7. Moving on to number 5. You have 3 different options here on payment methods depending on the payment method in the day. Number 1 is the medium of them. You stay for 9 days. But number 2, option 2, you only stay for 5 days. And it's the least amount of cost. Option 3, however, doesn't seem like it ever ends. It just keeps going because there's never really a truly end because there's a bunch of fractions. I have a graph of each one, and then I have a graph of all of them together. So option 1 is the middle option as far as days stayed and cost. Option 2 allows you to stay 5 days and the cost is the least. Option 3 allows you to stay the longest and you have higher costs. I would choose option 2 because it's the least amount of days and I can move on to a next project. Moving on to the last question. The carbon dating formula, where A is the initial amount of carbon and X is the number of centuries, which is 100 years, since carbon-14 started decaying. The function used is f of x equals, I'm going to have a hard time saying this, a of 0 to times the 0.0175x. So it's represented in the years and the percentage, what I have listed down, and you're trying to find the 0.37%, and that's located between 450 centuries and 480 centuries, and I wanted to go farther, so I made another chart over here, and I found out that it is between the 459th century and the 460th century, and I even broke that down more, and it was in between the 459.4 and 459.5 centuries. I have a graph that shows it, and between 459 and 460 centuries, the carbon-14% was 0.37. It took a long time for the carbon-14 to lose its percentage. The graph shows the percentage of carbon-14 percents over centuries. The function that was used in the making of this question was f of x a of 0.2 times 0.0175. This is my Module 4 Excel report for Miss Benzie's class of 2018.